Hello and welcome to another video. In this video we're going to be working on spiral matrix 3. And in this one you're starting at some cell of a rows by column grid facing east. In the northwest corner is at the first row in column, southeast is at the very bottom. You walk in a clockwise spiral shape to visit every position. Whenever you move outside the grid's boundary, continue to walk outside the grid but return later. And so they kind of show you this spiral pattern thing here, which is kind of weird. But there's kind of a pattern here. So essentially in this, you would go like this. Kind of hard to see. So you would go to 1, then to 2, then to 3, then to 4. So these are the locations. So this is 0, 0, 0, 1, 0, 2, 0, 3. And then this is the weird one. So they show you like, this is the numbering in terms of what you'll visit. So you'll go like here, 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 around this way, and then around. And there's a pattern here that you're going to be able to see if you look. So we go 1 to the right, then we go 1 down, then we go 2, then we go 2, then we go 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, and finally you're done after this thing. So essentially, basically, you start off going right. So you go right, then you go down, then you go left, then you go up. And every time you go, so you go 1, 1, 2, 2, 3, 3, and so on and so on and so on. And then basically what we can do here is imagine that this is out of bounds. We can still keep track of this index. So let's say this is some index and it's out of bounds. We can just track if it's out of bounds. And all we have to do, like let's say we start here and we're going right, we can just mark down every single node that's valid, and then everything that's out of bounds we will just ignore. But we're still going to keep track of the position we're in. So let's say we have some big matrix like this, for example. So let's just do a couple of these just to show what's going to happen. So let's say we start at this cell here. So we're going to mark down this cell as like visited, this index. Then we're going to go 1, 1. Then we're going to go, and as we go, like any cell we visit that's valid, we'll mark down. So, and we can loop this, right? Like we know we go right 1, so this can be in a loop. Then this can be in a loop. Then we'll go 2 left in a loop, so 1, 2. Then we'll go 2 up in a loop. And then we'll go 3, 3, and then 4, 4, 5, 5, 6, 6, and you basically just keep doing this until you visit the whole matrix. So 7, 7, 8, 8, and then you'll be out of bounds here, and then like this, and you'll be done. So all we have to do is just record which way we're going and our current location, then we can loop. Like if we're here and we know we need to go 9 up, we'll just go like 1, mark it, another one, 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 mark it, and so on. And then we can just record when our result is this whole grid, like rows times columns, then we can be done. So that's essentially what we need to be doing, and that's the pattern. So it's just, we just record which direction we're going and then how many moves, and then any cell that's out of bounds we just won't record, but we'll still record the index, and then any cell that's in bounds we'll add to our result. So let's do that. So here they have, I guess in Java you have an int array. So we can make this thing. So this will basically be an array of 2 integers. So it'll be like an array of a bunch of coordinates, and each coordinate is 2 integers and the number, so we can write down like total rows times columns. And then we can make this guy. So this will be a new int array, and the rows will be total, and the columns will be 2. And then we can just record like an index of where we're at. So maybe we'll call this I. Okay. And then we can just keep doing this until we're out of bounds. So we need a couple more things. So we need to know like what direction we're going. And the way that we're going to record the direction, much like in other problems. So actually, yeah, so we're going to record it like this. We're just going to say it's this. And it will actually look like, I think this is the format. So basically to go right, you go none down and then 1 to the right. Then we need to go down, so down is just 1, 0. This is what we're going to be adding to where we're at. Then we need to go left, so -1. Rows, we're going to go 0, and then we're going to go left here. And then up is going to be -1 on the rows and 0 on the columns. So let's think of something like this. Okay. And then what we also need is like what direction we're currently going. So we'll just say that's going to be 0. So basically this will represent right as in terms of XY coordinates. This is X difference, this is Y difference. So if you go nowhere on the X and you go 1 on the Y, then you're going to the right and so on. We also need to keep track of how many like moves we made, right? Because it's going to be like 1, 1, 2, 2, 3, 3, and so on. So we can say moves, we'll start that with 0. And then we're going to put the first coordinate into the result. So we'll say result 0 equals, this will just be row start, column start, and then we can start I at 1 actually. I think that's almost all we need, and then we can just keep doing this loop until we run out of space. So while I is less than result length. So what we need to do is we need to go in whatever direction we're going, however many steps amount of times. And remember, steps is going to be like 1, then 1, then 2, then 2, and so on. So steps will equal moves divided by 2 plus 1. That way, if we've made no moves, it'll be 1 step. If we made 1 move, it'll be 1 step. If we made 2 moves, it'll be 2 steps, and so on. So this is basically just going to end up being like 1, 1, 2, 2, 3, 3, and so on. Okay, so now we can loop through this guy. So for int something 0, j is less than steps. So what we're going to do is we're going to update our coordinates. Yeah, so we're going to update our coordinates. So this will be like, did we have our coordinates? No, so we need to also record a coordinate, so we'll do that as well. So we'll say x equals row start, or we can just use the row start and the row, well, whatever, we'll just do this. And then y equals c start. Okay, so to x, we will add directions at the index of the direction we're going and index 0. And y, same thing. Direction we're going, index 1. So if this is in bounds, then we need to write this into our result. So if x is greater than or equal to 0, and x is less than rows, and y is greater than or equal to 0, and y is less than columns, then this is a valid thing. So we can just add this in. So we can say result at index I equals xy. Okay. And then that's it there. And then once we moved, like let's say we're at something and we need to move some amount, then we need to change our direction and say we made like another, like we count each whole line as one move. So we can say here moves plus, because we want to make sure the next one is, you know, it goes 1, 1, 2, 2, 3, 3, 4, 4, and so on. And then we want to go to the next direction. So this will just be d plus 1 mod 4. That way, if we're like here, we'll go to here. For here, we'll go to here. For here, we'll go to here. And then we'll loop around to the start, because this will give us, from here, we'll go to 4, which mod 4 will go back to the beginning. So we'll go right, right, down, left, up, and then back to right, and so on, looping. Okay. And now we just need to return our result. Not sure if I made these array declarations right. We'll find out. Let's see. Probably not. Legal. Yeah, so I probably need like this, I guess. I guess I can always write it. And same thing. I forget when you have to write new int array and when you can just do this. But I know this always works, so okay. Okay. All right, there we go. Okay. So if you think about it here, from like as far as runtime, from this picture, here we're basically doing like a 3x4 grid because we're going one below and one above. So just to cover this row, we're actually doing like a 3x4 grid. So what ends up happening is the time depends on the biggest like of the row or the column, because we're kind of doing like a square move depending on that. So if there's only one row and a bunch of columns, we would go like far around the columns and so on. So this is basically going to be roughly the bigger, so max of row and column times itself. Kind of like you can see here, we're kind of going like a 4x3 here. And then space. So space, we're recording the result, which is every single cell, but we don't need to count that. Directions is constant. This is constant. So yeah, I think this is just O1 then. And yeah, kind of weird to do this like movement thing, but once you recognize the pattern that it's literally 1, 1, 2, 2, 3, 3, 3, whatever, and then all we have to do is just when we're out of bounds, just don't record that, and that's all we got to do. Yeah, so that's going to be all for this one. Hopefully you liked it, and if you did, please like the video and subscribe to the channel. And I will see you in the next one. Thanks for watching.